Hey everybody, welcome to Houdini Hangout. Hope you're having a great day today. Yeah, nice to have you all here. Just checking a little audio thing there. Yeah, hope you guys are all doing well, having a great week here. And yeah, welcome to the stream. My name's Peter. I am the host of the stream. And yeah, it's great to have you here. And yeah, so tonight we're going to be doing something maybe a little bit abnormal for the stream. We are going to be doing some rocket exhaust simulation type stuff. But first, we are going to, well, not first, but while we're doing that, we're going to have some rocket stuff happening in the background, and we might have a little bit of, oh, hey, Zach, how's it going? Hello. Nice to have you. Yeah, so while we're doing our stream here, and while we're starting to work on some Houdini stuff, we're gonna have the rocket launch stream in the background. So if you're not aware today, hey Procedural, welcome. If you're not aware, today there is a rocket launch that's kind of important. It's the first time that we've been had humans in the sphere of the moon, basically the influential gravity sphere of the moon, since the 70s. Yes, since the early 70s. And so we are going to be, NASA is launching a mission to the moon in approximately 20 minutes. And so yeah, so I'm gonna take a quick break and watch that while we're while we're here. So this is going to be a combo Houdini stream / rocket launch watch stream, which there's plenty of other really good ones out there if you want real professional commentary. But this is the only one where you'll get some Houdini work as well. So if you're interested in that. But yeah, so I figured why not do a little like rocket exhaust type simulation thing in kind of honor because of what we're doing today. And I think it's a nice positive bit of news in the world that's needed, that we can have some cool scientific advancements and things like that. So yeah, a big fan of space flight and you know, like all the sciencey stuff. I think it's a cool thing for humans to do science things and learn about the universe. So anyways, that's kind of the idea of the stream today. And it's going to be a little bit non-standard, but hey, I've been doing this for 5 years now. And no, sorry. Been doing it for 4 years now, roughly. It's hard to even remember. Maybe it's 4, maybe it's 5. I guess it's 4. We'll say 4.5. But I've never even like briefly mentioned this, and I always like watching good rocket launches. So yeah, so it's my stream. I get to do what I want to. So we're gonna watch a little bit of space stuff, and you can get my take on it. But for the Houdini stuff, well, for anything, if you have questions about rocket space stuff, I can hopefully answer that. I have a lot of experience watching rocket launches and have learned a lot about them. But yeah, so if you're curious about anything, whether it's the rocket launch or Houdini, feel free to put those things in the chat. It's it's a fun, either way, it should be fun to chat about it and have some discussion as we're working here. And yeah, so I'm certainly not the expert here on Houdini. We can watch the 80s movie Space Camp. What about, so Zach's mentioning that maybe we could watch Rocket Man instead. Do you remember that one from the mid 90s with the what's his name? I think he's like a comedian or whatever, Harlan Williams or something like that. Anyways, it's ridiculous. It's the stupidest movie, but I remember watching it as a kid. I never watched this 80s movie Space Camp, but anyways, yes. Yeah, so yeah, I'm not the foremost expert on Houdini. So if you have questions or thoughts or think of ways that I can do something better, or if I'm totally blocked, please feel free to share what you're thinking or how you think this should go, or you tell me that I'm totally messing everything up. Happy to hear whatever thoughts you might have. Put those in the chat. If you'd like to join the Discord server, you can go to houdinihangout.com, and there's a link there to join the Discord server as well. I often say that because everyone is around the world, it seems like there's lots of people on the Discord server now. I often wake up in the morning and have conversations, and I'm like, oh, what are people talking about? Which is very bizarre, but I really think that's super cool that people love the kids get launched into space accidentally in Space Camp. Oh, that's amazing. I've never seen that movie. Oh man, I might have to try to find that. I wonder if it's on any streaming services. I'll have to look. Anyways, yeah, so please feel free to drop your questions, comments in the chat. Heck, even space stuff. I like chatting about space. It's one of my many interests, I feel like, in life. So yeah, so we're gonna do some Houdini stuff and do some launch stuff, and yeah, cool. Well, why don't we kind of jump in and do some things here? So what am I on? I'm on the wrong feed there. All right, here we go. We got a little picture in picture down here, a little launch picture in picture, and oh wow, that's cool. Procedural. That's really amazing. I was in summer camp during the Apollo landing on the moon. Oh man, fell asleep before the main event. Oh, that's a bummer. Well, hey, hopefully at some point there'll be some more people on the moon, and you can be a part of that maybe. But yeah, that's pretty cool. I would have loved to have seen the moon landing stuff live. That would have been pretty amazing. That is something that's really interesting about this whole thing is like, I've never seen images of people live around the moon. Like, you know what I mean? Like that's never, like, I know all the historical, you know, archives of things like that happening, but I've never seen anyone doing that live, like in real time. So I'm excited about that. I mean, it's nothing we haven't done before, but it's kind of cool. I don't know. It's going to be neat to see it as a live thing and in HD and, you know, the quality differences and things like that. So that'll be pretty interesting to see. Hopefully they'll have some good footage of it. But anyways, so there's our little picture-in-picture down there. I also pulled up the this example footage here for us to take a look at, and we can see what this looks like here. Yeah, moon base would be pretty cool. I agree. So this is actually a full scale test of, hey Anya, welcome. This is a full scale test of one of the boosters. I mean, it's not one of the boosters that's on there. This one obviously was expended, but this is what the exhaust looks like from it. So I was thinking, oh, it'd be kind of cool to do something like that in Houdini. It's obviously insanely kind of massive, but you know, it's kind of a pretty good reference video there. hey Izafi, welcome. Yeah, rocket stuff is always fun. So a little backstory about me, which I may have mentioned before, but I used to live in Orlando for a couple years while I was in school, and yeah, I'm getting notifications here. Sorry, let me shut all this off here. Cool, that's off there. Let's shut this off here and make sure we're nice and muted here. Sorry. Should automate this really, but you know. All right, there we go. Hey Camille, welcome. Yeah, so I lived in, no, the rocket did not launch already. It's down here. There it is. And here's my version of the SLS booster. This is one of the solid rocket boosters that's on the side of it. So yeah, I finally got in time for a proper launch. Yeah, I mean, launches are crazy. I used to live in Orlando when I was, like I said, when I was in school, and I would go down to Cape Kennedy, not Cape Canaveral, I guess they call it. But I used to go down there to Titusville for launches. It was still the space shuttle program at that point, hadn't finished up yet. So I got to see like 8 or so shuttle launches, which was really, really cool. And actually my now wife, girlfriend at the time, we went down to see the last shuttle launch in person. So that was super cool as well. I'm going to up the quality of this because this looks like garbage. There we go. I'm actually going to listen into this to see if there's anything interesting happening here. I don't think. Oh, that's nasty sounds. Let me make sure I've got this set up properly so I can pipe it in if I want to hear the audio. Okay, good. That is linked. Cool. Let me see here. Cool. What's the exact mission of this launch? So this launch is the first crewed mission of the SLS rocket, which is what you can see there. That's a top-down view of it, right? So they've launched this uncrewed once, and now obviously there's a crew on board. And so their mission is going to be to orbit the Earth for a few times, and then they're going to do what's called a translunar injection, which is going to send them off to the moon. And they're going to go out to the moon, kind of slingshot around and come back, basically, just testing out this system. In the Apollo era, they did that for Apollos 8, 9, and 10 before they did the landing on 11. This one will be I mean, as long as this timeline continues, I guess I mean the NASA timeline, not like our lives, but as long as this NASA timeline continues, the next mission, Artemis III, should be a landing on the moon. This is just like a kind of an orbit. It's not really technically orbiting. It's just going out, slingshotting around, but it's close to an orbit. So yeah, that's what they're doing. And so yeah, I've had but there's a bigger goal than orbiting the moon. The ultimate goal is to land on the moon again and set up some research bases and things like that there. Kind of like they want to do, I think, more or less what they've done with the International Space Station over the last 30 years, where they've had a lab basically that they can do science in these different places and learn new things. So that's kind of the idea. But yeah, that's kind of the mission of this launch is kind of a test of the system. It's kind of a test launch in a way. But then they're going to get into more serious missions in the future. But yeah, it is cool. I agree. And so this launch pad is one of it's in, like I said, it's in Cape Canaveral in Florida, and it's one of the launch pads that the shuttle and the Apollo missions used before that. This is 39B, and 39A is now owned by SpaceX, well, as leased probably, but so this is one of the launch pads that they used for that, for those other missions. So they're using some legacy hardware, but yeah. So yeah, there you go. We're at 10 minutes. All right, so they are holding question mark here. Sorry. This will let me know if I should just jump over into some Houdini stuff now. Interesting. Looks like they might have a little hold here. So it was minus 10 minutes ago. Oh yeah. Right. It's at sorry. Yes. That's the actual time. So they were in a planned hold for a little bit. And so this is actually just the time that's holding. So yes. Oh, I reloaded it there. Sorry. Yeah, this website is not going to tell me the proper things anymore, so that's okay. We're just going to pull this up here. There we go. So yeah, so this basically just means that they have these like built-in holds that the clock is stopped for, so they can just kind of sit there and just kind of wait more or less until it's time to actually go. But is it reusable? Probably parts of it are. It's not reusable like the SpaceX rockets are that land back down on Earth. This is mainly, it's actually kind of all heritage stuff, basically all heritage elements from the space shuttle, because it's like the booster that you see here on the screen that I have, that's actually like just a slight bit longer than, it's one more like module, like those little those little lines there. It's one more of those, I think, than the solid rocket one, or it's like one, like maybe two of those are in a pair and it's one section longer. Those are like kind of reusable. They used to splash down. But like the main orange tank will actually, at least it did on the shuttle. It should probably burn up on this, on reentry. That's an interesting question. I actually don't know if that will totally burn up or not, but yeah, not a ton of it's reusable. Unfortunately, NASA didn't really go in very hard into the reusable stuff. And the shuttle was actually kind of a big failure because it was reusable. That was kind of a big problem. So, yeah, anyways. So like, it's not quite like SpaceX is with their Dragon system. So they're doing a little, I'm listening to them chatting in the background here, but all right, so I will just let this kind of go here because it looks like they're trying to figure some stuff out. So let's take a look at some Houdini stuff while they're figuring out their countdown over here. This is what I've got set up right now. It's very simple. I think I found this like STL file online. This is the actual rocket here that we're looking at. Nice, lots of reverse normals on it, which is always delightful. Could I check out the pyro thrust exhaust? Oh, you're talking about the new... Yeah, I can take a look at that. I actually haven't played around with that at all. But yeah, I'd be happy to mess around with that in a second here. So here's the rocket. And so what I did is I just threw a connectivity on it. I just set this up like 2 seconds before we started the stream, just so I made sure I had a decent little model here to use just for some reference. And... So the connectivity node is looking at rocket launch in Houdini. Yeah, pretty much. It's like real life / Houdini rocket launch. So what the connectivity node does is it's kind of like a core type node. It's very useful. It looks at, the 3D connectivity of geometry in, whether you're looking at it. I think it mainly looks at the primitives, right? Like if they're all connected, and then you can put that attribute either as a primitive or a point attribute on your mesh here. So you can see here that we have a class attribute now. And so each and every one of these is going to have their own class number. And I'm actually just gonna turn this off so that we're not dealing with that inverted color. But so let's visualize the class here. And now you can see that each of these pieces here on the model have their own, colors. Basically, these are driven by the attribute. So that attribute is making each of these sections kind of have unique attributes, and those are these numerical values down here. So each primitive now has their own number. And so basically what I'm doing is I'm just blasting out one of those numbers. And the reason I did that this way was just so it was a little bit more procedural, right? Like instead of selecting random primitives, we're selecting an actual attribute to go with. Then just match sizing and transforming it down into this kind of horizontal position that we're going to use for it. So they're all talking here, so here I can turn it on real quick. So cringy, all of the like all of the stuff that people are talking about. All right, we'll leave their cringy little speeches for right now. So basically connectivity object takes complex objects and separates the individual pieces. Yes, exactly. And it should do it in a fairly repeatable manner. Now, obviously I guess it just makes it so that you're not depending on a actual selection. So you can just use the attribute then from that. And the only problem is if your mesh changes drastically, especially with the number of connected pieces, you could get, some randomness in which piece gets numbered which. You don't have a ton of control over that. But yes, it does. It's helpful for that. Like a name attribute or like a what do you call it? Like a what's the word? Like a material attribute or something like that would be a bit more stable to select with. But this file is just literally just point positions. It's just an STL file. So there's nothing in there. Like if it was an FBX or something like that, that would be useful for it. But it's always, good to kind of play around with your geometry as it comes in and kind of see what makes the most sense for it. So yeah. Okay, so that is the geometry in here, and I am just going to, sorry, just moving my water out of the way here. Let's put a null down. Okay, so we've got our rocket here. Sorry, I'm sort of listening in the background here to to the what do you call it? The this down here. I don't have the music, or I don't have the audio on for you guys, so you don't have to be bothered too much by it. Let's call this Geo Rocket. All right, so let's do another geometry node here, and we'll do the sim inside of this. So we'll say sim rocket. All right, so this is, so what they just said is they are getting ready to check a couple things, and then they'll go into what's called the terminal count, which is basically when the rocket is kind of in, not totally, but the rocket's kind of in control of the launch at that point. So, so the computers in there are in charge. Anyways, how can you follow along? Oh, with the launch? I will unmute it if you'd like, but they're talking, so it might be weird for me to talk over them, but, like you can actually, I will have it so you can hear it. Oh, with the Houdini. How could you follow along with this? That's a good question. I don't have this. I actually don't know if I'll be able to have this file here. I will eventually put these files up online and you can take a look at them. What I'm going to do is really not going to matter too much about this, this geometry here. This is just for my own, like, just to have something a bit more realistic. I mean, you could just do like, you know, do like a tube, something like this, and just put it in the z-axis like this, and just, you know, make a tube or something like that, and just, you know, you could do your own shape like that, you know, and just have some of your own, something of your own to kind of work with, and just extrude that and stuff like that. So you could do that, but I won't probably distribute this file, so that will actually be like missing, but it won't really matter. It'll just be an error. Like, it won't, the sim will still work basically. So actually, you know what, I could probably put a stash here. I'll show you what I'll do, something that should work out okay. So let me do an object merge here, and I'll just stash it in. All right, so we'll say get their clock is wrong. They're at T-minus 10 minutes, not 26. Get rocket. All right, and we'll grab this from the rocket. All right, and I'll just do a stash. This is actually going to save just this geometry in here, so I'm just going to stash the input there. So this will only, if I need to update this, I'll have to restash it. But for right now, that should work. So yeah, so when you open this file from it's on the Discord server. So if you join the Discord server, HoudiniHangout.com, you can go there and find a link to the Discord server. From there, you can find all of the files from these streams. So obviously I won't be putting them up right now as I'm working. That would be kind of crazy. But, you know, for the not too distant, you know, by the end of the stream, it'll be up there and you can take a look at it. So anyways, so we'll do that. And then that way we should be good. All right. Well, now that we're going here, I'm going to switch some things around here. So let's do this. I'm just going to crank that down, and I'm going to turn this down, and then we can just fade that in.
To the next holding point. So the clock won't stop right away. If there's an issue, we'll go to the next stable holding point.
So you should be able to sort of hear that.
This is how GLS configures the rocket and ground systems.
So I'll just keep that low.
They can stop the countdown if that's
Like that, maybe.
But right now, we are
so yeah. So they're actually counting down with this launch. So there we go. We're going to make it bigger. We'll watch along. Only a couple minutes now, so.
And there you see the crew access arm moving away.
Yeah, so that's where when you watch like the videos of the crew getting into these rockets, that's where they get in. That's what I just said. So yeah, only a few minutes. So either this is going to happen in a couple minutes, or probably it won't happen today at all. So that's a good sign. They're not in some weird hold long-term looping thing that can happen. So when I used to go down to the Cape, I would drive down there to like I said, to Titusville, and there. Wow, that's a camera on the rocket. That's crazy. I used to drive down there, and it sometimes be like 2 or 3 in the morning, and the whole launch would get scrubbed, and then I'd just be like, okay, guess I'm going back home. Nothing happened tonight. Drove out here at 3 a.m. But yeah, anyways. It's really crazy to see this rocket versus like SpaceX rockets. This rocket has so little venting happening. Like you can see right there, that's that little bit of venting that's happening there because all of the fluids in there are cryogenic. And they're for Falcon 9 on SpaceX, that's like there's literally like gases coming everywhere out of it. But they also don't keep theirs fueled as long as NASA does for a lot of their rockets. So and there was controversy about that as with many things. But anyways. Also, I think you can see right there, there's these 4 like little boxes on it, and those are actually little baskets that the crew can ride. They're like zip lines that go down and would take the crew away if there was an issue on the pad, and if people couldn't come back to the launch tower. So pretty cool.
The replenish valve for the liquid hydrogen tank has now closed, and that tank is beginning to pressurize to flight levels. Because that hydrogen is naturally boiling inside the tank.
So I used to, it's funny, I've watched so many of these launches, not this rocket, this is a very new rocket, but I've watched so many shuttle and SpaceX launches that,
the Artemis II crew could use the launch abort system to pull Orion safely off the top of the rocket in an emergency.
Yeah, so that's another good thing to note here, that if something really crazy does happen here and the thing blows up, there's actually a pretty good chance that they would all be safe, because this isn't like the space shuttle where there's nothing you can do. They can actually pull away from the rocket and be safe. So if something really crazy happens, which is not 100% guarantee that it wouldn't happen, just don't worry too much about that, because actually not too long ago in Russia that happened. They had a situation where they had an issue at an ascent, and their rocket saved them. Basically, their capsule pulled away, and they were safe. And the Russian system is like, it's like a bunch of like, I don't know. It's very simplistic compared to a lot of the systems that are on some of the more modern rockets. So I think it would be a pretty safe bet they'd be okay. But yeah, it's really weird. It looks like a space shuttle just without the shuttle on it. It's very strange. I was actually in LA a couple weeks ago, and I was really bummed because they actually have a space shuttle in LA. I've seen it before years ago, and they have it in this big, huge 200-foot tall building. And you can see the outside of the building, and there's a space shuttle standing vertical as if it's on the pad inside of it with the orange tank and the white boosters and everything, like all technically real flight hardware. But you can't go in it because the exhibit's not finished. So everything's in there and you just can't see it. So I was really bummed. I was in LA and I was like, man, I would really like to go check this out. So sorry if you showed up here for 100% Houdini action. It's right now we're in rocket mode. So once this happens, we'll get over to we'll get back into some Houdini stuff. So if you're here for the Houdini and you're annoyed, apologies, but I like rocket launches, and so I'm going to watch this one.
moving through the milestones. All is looking good.
I'm using the NASA feed here because they I don't want to use it. Like, there's a lot of other really good commentators and stuff out there that do really cool feeds of this stuff, but I don't want to rebroadcast their stuff. Like, NASA is whatever. Like, that's a public. Like, I pay taxes for NASA, so like all of their footage and stuff is like they just release it for free. So I'm not too worried about restreaming NASA stuff, but you know, other people's stuff. Their commentary is much better, but oh, cool. You can actually see the engines there in the middle. They're doing gimbaling. So they're actually testing, because these engines at the bottom of the orange tank actually can steer the rocket. And so they're doing a gimbal test. So they call this thrust vectoring, and they do this test on the engines. They used to do that on the shuttle too as well. The shuttle had the exact same engines on the back of it, just 3 of them instead of 4. And so yeah, they used to do the same test. And these are the same type of engines that you would see, that kind of iconic shot. Yeah, no problem. Watch on your TV. Yeah, go for it. Those are the same engines that you'd see those like sparkly, like the sparklers that were like going around and like kind of burning off the excess gas. I don't know I guess they probably should have those here, but like I said, I've only seen one of these launches before, and I don't remember if they use those or not. So everything's sounding like they're in a good spot.
There's no more hold time because there's no more margin on these batteries.
Hopefully hopefully that's not too loud.
To recharge if we had a hold.
It's actually probably pretty quiet actually, so
1 minute.
Right now, the rocket does not know what the T0 is, but coming up at T-minus 33 seconds, control shifts from the ground launch sequencer to the rocket's onboard autonomous launch sequencer, or ALS.
There we go. I was off on that. They're now in the. They're now going to the rocket.
Houston will take control of the rocket, and my colleague Gary Jordan.
You're nervous. Oh man, I've watched a lot of these in person. Talk about like actual nerves. That's intense.
The rocket is on its own. 4 brave explorers ready to ride the most powerful rocket NASA has ever launched. Sound suppression water is flowing.
15.
And
oh,
here
their
we go.
clock was off.
10, 9, 8, 7.
Oh yeah, there you go. There's the sparklers.
5 engines lit. 4,
Sick.
3, 2, 1. Booster ignition.
Wow. Cool. They did it. Can't stop it now. Whoa. Jeez.
Now bound for the moon. Humanity's next great voyage begins.
That was interesting. You can see the baskets from that escape system going down there. That was really odd. Wow. Very cool.
Houston now controlling the flight
So they
on the Artemis II mission around the moon.
They almost instantly start turning because they want to start tipping the rocket over as kind of so that they're not fighting gravity as much and moving more with it. Ooh, that's a good.
Target milestone. Mission Control Houston seeing good performance on board engines, Space Launch System core stage.
So that popping, it almost sounds like popcorn in real life. And that's like supersonic gases and stuff, like leaving the exhaust. One of the coolest things about rocket launches is that you see this. Oh, that's an interesting shot. Who's directing this? So you see the especially like it's probably a little too early in the day, but when it's like close to sunset, it actually is like it's almost like a rainbow because the exhaust stays for a while. And yeah, so you would see it like you almost see it like going up into the sun like a sunrise. So it's pretty neat. There we go. Much better tracking. So these cameras that they track this with are like these huge like binocular like telescopes that are basically on this big fork mount, and they follow the ship as it goes up, and you have this like really hey Carlos, how's it going? they've got this like, I guess they kind of use like a joystick or something like that to like, yeah, nice pyro sim. Exactly. Hey, Fractaler, how's it going, man?
We see
Oh.
throttle down.
Cool. Yeah, show the people. Yeah, we know that there's people there.
Main engine
Oh,
ramping up, guidance
okay.
converged.
Well, that's cool. So the solid rocket boosters are now off, and you see them flare out there because like those, once you turn those on, those can't be shut off. They just burn.
Integrity, guidance converged, performance nominal, upper stage
Nice.
RTS ready.
So there you can see kind of the coast of Florida there and that. The crazy thing is you can actually see these dots from the ground. Like you don't need a telescope or binoculars or anything. You can actually look up and see the like dots in the sky from all this stuff. I mean, obviously binoculars are helpful, but you can actually see it in with your naked eye. Really, probably until they shut off those engines, you can't see it. But it gets to the point where you start noticing that they're going like away from you, and then you start realizing they're going. You're watching them go off into space around the Earth. It's like a real bizarre feeling to like realize you're watching someone go, like seeing someone be in space. Like they're in space pretty much right now. So that was just a shroud that was around probably the like service stage or whatever. So that just came apart so that things like what do you call it, like solar panels and stuff like that have room, you know, to do it. And now I think they've also jettisoned there was like a shroud that was surrounding their capsule, and so now that's gone as well. And that cloud stays like that for quite a while after the launch, and it's really pretty amazing how long that kind of drifts in the air for. That exhaust stays there for quite a while. And you only get that on launches with solid rockets. So like SpaceX launches don't have that long trail like that. So, man, I wish we didn't have all these people talking. Yeah, looks like things are going pretty well. I'm surprised they haven't showed any internals. So MECO means main engine cutoff. So that's when those engines are going to stop firing. So you can see here, there's almost like this like weird like jellyfish pattern happening. And if it's sunrise or sunset as well, you can actually see those patterns up in the sky. Like you can see those with your naked eye. Like right now you can't because it's not dark and those aren't getting hit with light. But, you know, you actually see those in Los Angeles sometimes when SpaceX launches, because there's a launch complex there. That's the astronauts. They sound so goofy right now. But
we see the same, and we have a beautiful moonrise. We're headed right at it.
Now, I should note that they're not heading right to the moon. That's not accurate. They are they're actually going to be going around the Earth for a little bit before they head off to the moon. Because you can't just fly right there, basically. I mean, technically you probably could, but you don't do it that way. It's better to kind of wait in these patterns, like orbit and then blah blah blah. So they're calling out things there. They just said three engine press, and so there used to be all these things with the space shuttle where they would have these different like modes where you could like, if we lose 2 engines, we can go, or like if we lose engines, we can abort into orbit, or we have to abort back to the launch site, or things like that with the space shuttle. They just said they can basically push to orbit with just 3 engines at that point, and so there's different abort modes that they go through as they're going up, and they get lesser and lesser importance because they're higher and higher, going faster and faster. And so really that's the key, is like it's not about getting up high, it's about going horizontally fast. Like they're not at that high, but you can see how much they're tilted now, and that's the whole point of it. So now they're going 11,000 miles an hour, which I think the total orbital velocity is like 23,000 kilometers an hour, I want to say, or something like that. But they're only 80 miles up, so they're not like crazy far away. So, but yeah, it's pretty interesting. Oh, that's the plume. So that's from inside of the launch, like the firing room at the launch pad. So yeah, these things burn for a long time. Like at first, those solid rocket boosters do most of the pushing basically. And then at this point now they're 100% on just the center core. Those things have fallen away. And so they're pushing those engines really hard. So those can burn much, much longer. That's not the best shot I've ever seen, but they got to work on their exposure there in the middle. Kind of saturating the Kerbal Space Program. I love Kerbal Space Program. I never find many people that know about that, but yeah, I love Kerbal Space Program. Chill orbit for a couple days. Yeah, exactly. Really, I don't know how like crazy it'll be. They're not going to be doing like a ton of stuff. They don't have to do spacewalks or anything like that. So right. So they just said that if they aborted now, they could also do an abort and go around. It basically will shoot them all the way around. What they've launched so far will propel them all the way to the Pacific Ocean, like basically on the other coast of North America. Got it for free on Epic. Oh wow, is it free now? That's crazy. I guess I didn't really even think about that because yeah, it's basically all shuttered. But yeah, it's a great game. I was really hopeful for Kerbal Space Program too, but that didn't go anywhere really. Oh, cool. There we go. Looks like we have they've separated there. So that is the top part, just the white part up there. I pirated it before that. I won't tell anyone. Although you did just say this on the internet, so I don't know who would come after you. I think the company's closed. But yeah, so now the white part is separate, and that's
40 seconds into the flight. We have a nominal main engine cutoff heading and
nice.
Trajectory on the way to swing around the moon.
Very cool. Looks like I don't know what we're looking at here. I've never seen that before. Oh, right. So technically the spacecraft here stops at the kind of skinny, there's like the capsule at the top, then there's a skinny part, and then there's a thicker part. So that thicker part will actually come off. That's going to propel them to the moon, and then the top part will come away. But yeah, so they've separated that, then they open the solar panels, and that's pretty much that. Cool. Nice. Well, there you go. That's pretty much a rocket launch. I can't think of that's about as smooth as it goes. I mean, that was good stuff. That was really, really nice. Here, I'm going to mute it for you so you don't have to listen to them chatting away. But there you go. Little space launch there for you. All right, let's kick this back up. Nice. All right. Yeah, it is very good pyro reference. I agree. I also had this one too that I was showing, which is pretty good pyro reference. This is what we're gonna try to do something sort of like. This is crazy. Like they actually this is in Utah. They do this. Promontory, Utah. This was several years ago. 2020. Anything happening that year? But you can see how crazy it is. Like just insane amounts of just like all this dark stuff I think is actually just dirt coming up from the ground because it's just insanely powerful. I don't know how they can keep this down on the ground. It boggles my mind that they can keep this thing stuck to the ground. It's insane. Like, I mean, there's big clamps on it, but that doesn't seem like enough. But, you know, I guess engineers are smart people. Anyways, that's what we're going to try to do. Okay. All right. Well, there you go. Rocket launch. Let's see what we can do here. So that's so funny. I see a little thumbnail of my stream with the rocket launch in there. That's funny. Okay. So let's get back to some Houdini stuff here. All right. What should we do here? Let's do a circle. We'll throw that in there. This will be our emitter, I think. Because I don't really we could take this, but don't really think we need to. Good game, Izzy. Did I miss something? What's IZI? Not sure what that means. Maybe I'm missing something. All right, so let's grab this. And let's make this bigger. And I'm going to... like easy do the rocket. Yeah, the easy mode in the computer. Yep. Although for them, they just get all the details and stuff for free. I mean, we have to like, you know, they just ignite the thing and it looks like a rocket launch because it is a rocket launch. We have to like figure out how to make it look like something, I guess. No, obviously they have the actual hard part. But it is interesting. All right, so we'll put that in there. That'll be like our emitter. And we'll maybe use this as a collider. We could probably do that. But we'll just get this like working here. So let's do a pyro source here. Throw that down. And let's do a surface scatter. That should be fine. Because the scale of this is so big, you're going to see that there's a lot of particles here. Really not necessary. So let's maybe change this to 1. No, it's probably too little. Let's do 0.5. Obviously, this can be something to keep in mind with a lot of Houdini stuff is that, you know, things are often made at the scale of like, some might say it's rocket science. Yeah, it almost is. So one of the main things to keep in mind here is that like a lot of this stuff has to be designed with defaults at some scale, right? There has to be some type of scale. And in a lot of cases, it's like in a meter, like the unit kind of meter range. And so when you get into these really large, like this I looked it up to see online how big it was. And oh, I was looking at the wrong scale. Yeah, that's not right. That's way too big. I'm gonna go back to this. Scale it to the proper scale. I was looking at the wrong thing. I was looking at... It's supposed to be 54 meters, but not 560 meters. It's supposed to be 54 tall, and I looked at the wrong thing. So let's scale this down. That's way too big. I want it to be relatively correct. All right, so let's do this. Oh, maybe it was to scale. I think just burst for 2 seconds and it's, yeah, exactly. It just basically just goes and it's up there. Another funny thing is my dad and I used to make like hobby model rockets, but like high powered ones. And so we used to go and do stuff like where we'd do really crazy, like powered, like high powered rocket launches with like we didn't really get into the multiple stages and things like that, but we did some that would go pretty high, like a few thousand feet, stuff like that. So it's pretty neat. It was fun to do. Let's see here. You had to get you had to do a certification basically to be able to do it. Cause obviously they're not just gonna, it's literally like putting bombs out in like a field and just hoping that they're going to go upwards and not towards people. So you had to kind of do some like testing and stuff, but a lot of like the that just made me think of it because some of those engines are super quick and fast. Like they just go and it just shoots it up like, you know, a few thousand feet and like with like a 2-second burn basically. But anyways, yeah, so like the ones that you would do in like as like a hobby model rocket, like in like the store that you could just randomly buy, those would get up to like, I want to say like C, D, maybe E class engines. And I'm pretty sure for one of our later ones, we got to like M or N or O, somewhere around there, I want to say. And they were maybe O, maybe we did an O engine, and they like scale up quite a bit at each like level. So yeah, they were pretty beefy rockets that you could mess around with. And other people there was like people that would do like, I don't know, like 10th scale like rockets that they'd launch, like Patriot missiles and stuff like that. It was absolutely insane. It's like, this is craziness. I think I watched one of those blow up, and it like one of the model ones blow up, and it was crazy. It was like the wildest thing. It's much nicer to watch that blow up. I'm glad I've never seen a real rocket blow up. Anyways, let's bring this back over. And I'm glad I was talking about that because I would not have noticed that this thing was like the output of that. It was like the size of this whole rocket. Oh, that's funny. Okay, I should have started putting some things together when this was like saying like 10 meters and the whole rocket's 50. That's a problem. All right, so this is probably like 2 meters. There we go. See you, Carlos. Thanks for stopping by. It was nice to have you in the chat. Thanks for making us stop by. Appreciate it. All right, let's throw this in here. I mean, really, all of my same comments apply. That you want to make sure that these things are set at more or less like that meter unit. But now, when we look at this, it actually should be really good because yeah, this is going to be just about 1 meter. This like circle that we're going to have here. So. I don't really want this to be going into the into that. So let's do all right, let's do like 1.25. That seems good. All right, something like that maybe. All right, let's look at this. Yeah, let's give it a little bit more. Yeah, that's nice. That's probably good. We could always up that. All right, so there's our pyro source. Now we got to do a volume rasterize attributes. Drop that down. So what we need to do is we need to rasterize our attributes that we're putting in here in our pyro source. We don't have any attributes, so let's do this. Let's do source burn, and that should be what we need. Yeah, Axiom is Sklabadur was just saying in the chat that he wanted to do something like this, and yeah, I feel like I've never really made a very good rocket, so this might not look very good. Hopefully it looks okay, but yeah, he said he cheated, quote unquote, by using Axiom, but I don't think that's a cheat. I think that's a good idea. I don't have Axiom, so I probably should get it. Be nice to play around with. I know it's really good and pretty fast. I've played with it before years ago, but I think maybe only when it was free and only just kind of tested it out. But all right, so volume rasterize attributes. Let's come in here. Let's grab burn. I looked at P and burn and said burn and temperature. We also are going to want to put some velocity on this, I think, because this is like at this point, this is not where it's like burning. It's like it's coming from up here and it's already got a ton of velocity squeezing it out. So let's give it some velocity. Let's do just do a point velocity node. And we'll just say set to value. And let's do this. Let's see, in the z-axis, let's do, I don't know, 50? I don't know. Let's start with 25. I mean, that might be crazy. I don't know. Got to think about this. 25 a second, maybe? That's probably not enough. We're going to need way more than that, I bet. So let's say we'll do it. I think this is like 50 meters a second. Oh, wow. That's interesting. They're actually burning the, here, I'll show you. They're actually doing a burn. Now you can't actually see it. This is just a visualization, but they're actually burning this engine already. So what they're doing is they're circularizing their orbit. So that must have meant that so the apogee is the high point of their orbit. The perigee is the low side, if you've ever played Kerbal Space Program. But what they had to do was raise up their perigee so that they wouldn't come back into the atmosphere too much. And so that's what they're doing right now. And they've already opened up the solar panels, it looks like. So they're cruising along. So that's cool. They had another burn. So basically that's just getting them into a stable orbit, more or less. Like the shuttle would sort of, actually, no, maybe they didn't get right into a circular orbit, but they got into a stable, like, initial trajectory. I don't know. I guess I don't remember if they did It's been many years since I've watched a shuttle launch. So, anyways, cool. All right. So point velocity. So if it's 50 meters a second, I think that's what we're looking at here. So let's do that. Let's throw this on. I'm going to turn this off for a second. We can leave it. Let's hide other objects. We can use that if we want to. Let's add some conical noise, I think will be good. I'm using the wrong thing. There we go. And let's add some conical noise here. All right, that looks pretty good. I'm just adding a little bit of noise here to these points. Oh, right, and the direction is in the wrong angle. We want this to be in Z. There we go. That should be right. Yeah, there we go. So now we can control this properly. Yeah, you can see obviously now we're getting more of this, but we don't want to go that crazy. So let's just do like maybe 10 degrees, just a little bit of noise there. That should be good. Give us some interest. I think we also might want to put some, let's see, can we just do a $F on this? Yeah. And then maybe we add a little bit of curl noise in there too. Let's see what this looks like. Actually, no, let me just turn this off for a second. I just want to see what the, delete channels here. Let's throw this curl noise on. You know what? That's probably going to be fine. The only thing I'm going to say is maybe we do it. Can we do 0 in the Z? Huh. Yeah, maybe we just do that. That was weird. Yeah, let's do that. And instead of the conical noise, so we'll turn that. Oh, was on, just wasn't animating. All right, we'll leave that on. That seems like good. All right. So we've got that. We've got our point velocity. And just remember too, what we're doing here is we're taking these point velocities and rasterizing those into volumes. That's kind of the more modern way of doing this. Burn temperature, let's grab V as well. And here we're just going to say burn is going to be the visible volume, I guess. All right. Let's do normalized by clamp coverage. Oh, let me do the dark. So we can see what's going on here. Oh, good question. Ibo was asking, will a sim like this have divergence? Yeah. That would be something that I would want to have as well. And that's a good call. We can set that up right now if we want to. I was thinking that we will need that. And yeah, I'm just trying to think. I mean, we definitely want divergence. Yeah, so let's do that. Let's add an attribute here. Is that the right spelling of that? Gosh, I'm so bad at spelling. Yeah, that's right. Man, I have a lot of respect for you folks that don't actually speak English as your first language and have to remember how to spell English words that I have a hard time remembering when I'm supposedly a native English speaker. Yeah, Ibo, you're right. It's directed. It's a directed flow, but it is also diverging. So yes, for sure. You definitely want some divergence in there so you can get some of that like billowing and things like that. It is hard because let me pull this back up again here. If you watch this kind of flow that's happening here, it is very much like a tight, that nozzle is really pushing it in this like kind of tight area. And it doesn't start really pushing out until later, but I do think you want that divergence in there so that we can really see that, it is trying to push apart because the pressure is incredibly high inside of there. That's how the gases are getting pushed out the other side. Yeah. And you do see some billowing there. Right about here, if you look real close, it is quite smooth there, especially when they're in flight. You see it even smoother because obviously you're getting the wind is the air is pushing it. But yeah, certainly it pushes out quite quickly. But yes, for sure. So let's do that. And actually, you know what? I'm just gonna remove this here. So let's just remove this. I'm gonna do an attribute, just float, just because we can create the attribute the same way this way. And let's just do divergence here because we're gonna need this anyways. And it's just a little easier just to know. We're just gonna say add diverge. And let's visualize that. So let's turn this off. Let's visualize this. Let's do a noise on this. And I think we want this element size to be a bit smaller, maybe something like that. The other thing that I don't think we really want to have is, I don't think we want to have like this 0 to 1. So let's do this like, let's do this. Let's do a middle and range length. So let's do our middle value at 1 and then our range length at like 0.5. And then what we could always do here is we could do a post process on it. Oh, I thought there was a multiplier here. That's a bummer. I was thinking we could do a multiplier down there if we wanted to, just to get ourselves like a nice kind of middle value here. Yeah, so Izafi was asking which one is right. You position the circle density source at the mid position of the rocket nozzle. This is an option. So let me just turn this back on here. Boom. Sorry. So yeah. So I've got it at this middle point here, kind of. So the sim expands, divergence, smoke, and collides with nozzle. Which one leads to a more realistic sim? So I think it's, truly, if you were doing like, this is like, if you were doing like an engineering study of this, right? Like this isn't truly going this small. I think there's like a point here where it gets like that kind of cone gets truncated, and that's the opening, right, for the nozzle. I want to say it's probably about here, honestly, if I'm guessing. It's probably in this range here. And then that's where, because it does not going from this little tiny hole. There's actually like, I think there's a big enough hole that you could like, I think you could actually climb through this. So this is a gigantic hole in the middle of this because this thing is how many meters tall? Anyways, and so if you had it start right where that cone is truncated, let's say up down here, you have to rely on the divergence to push it out to the full width of that, right? And then like if you're starting from a really small circle, you have to really, really rely on, oh, okay. Interesting. In my experience, sphere source gave me a much better realistic results than a circle. Interesting. Okay. Yeah, we can do that. Did you fill it volumetrically? Yeah, let's try it. Let's do it. Okay, you filled it volumetrically. Nice. So let's do a volume scatter then. Oh, that's way over there, right. Let's see here. I'm just gonna copy this parameter and just paste the values here. Great. And I think what I'm gonna do is, did you like squish it? That's kind of what I would think. Like, you probably don't want it to be an actual sphere. You want it to be like a kind of flattened sphere. So let's do that. Well, how big was the circle? 1.25. All right, let's do this 1.25. And which other axis are we looking at here? Is it this one? 1.25. Yeah, there we go. So maybe something like that would be nice. And then we can always control it, the thickness of it with this here, right? So, I mean, we could do 1.25 here, but that's a little strange because it's kind of like small horizontal squish. Yeah, there we go. We're gonna try that. See how that goes. Cool. Yeah, thanks for the little tip there. Appreciate it. There we go. Okay, so there's our divergence, and I want this to be animated, so let's turn that on. And let's do the pulse duration much lower. Yeah, something like that seems good. Yeah, great. Okay, so we've got burn, temperature. Let's throw in divergence there too. Just to see what I'm doing here, I've got attributes and I have the visible volume. So just burn is visible. I don't really need to see all of the other attributes and stuff like that. The other thing too we might want to do is actually noise up the temperature field a little bit. That should help us to get some better results. So what we can do there is we can do another attribute adjust float. And let's take temperature here and let's do, we can add to it. Let's visualize that. So there's our temperature field. And let's do a noise. And again, we're going to do the middle and range length. Let's do the middle value at 0. That makes sense. And then we can just add a little bit of noise into it this way. So we're adding 0 and plus or minus, 0.2 or something like that. Just a touch of. So I was saying the thing is divergence will push the smoke everywhere, right? Yes, it will, but because we have the velocity as well, it's really going to be kind of those two things working in conjunction. So the divergence will be pushing it outwards, but kind of in that direction. So that's the idea at least. Also, if we have the nozzle in there as a collider, that should help it from going backwards as well. So, okay, there was a question I saw before here with Camille saying, could you explain stash node as if I were 10 years old? I am. Oh, wow. That's crazy, Camille. That's cool that you're doing Houdini. You only started Houdini 20 years younger than I did. So that's cool. It's very impressive. Okay. Stash node. Very simple. What a stash node does is it's taking the incoming geometry and storing it basically within the HIP file. So it's not storing it as a file on disk. It could store it as a file on disk. You can see here is a geometry file node. So you could say move stash to a new file, and then basically that's going to save whatever's inside of it to a to a separate file. But in this case, I want it to actually be stored in my HIP file. So this stash is basically it will always remember and keep what's in here. So it's kind of like it's storing this sort of in memory more or less right now. And then when I save it to disk, it's going to be saved in the HIP file. So like when I hit save on this HIP file and look at my Houdini Hangout project files, my rocket exhaust file should be fairly large, right? So I've got this 2.32 kilobyte version. I'm just going to do this really quick and just say no stash. Just save that for a second. And just hit delete here. And now so now you see they're the same file size, but if I hit save now, it should be much smaller. And there it is. So it's about 2 megabytes of data that it's storing for that stash. So it's actually getting saved right inside of that HIP file. So there's a little example of what it is. So I'm just going to go back to the exhaust hip, and we'll go into the sim rocket unless it cooks. There we go. Interesting. Sklabadur said, how is this stash node different than a file node? When do you read and write? So this stash is read from the file itself. So there is no, unless you're doing something here. So what's the benefit of a stash node versus a cache file node? A cache file node is going to save it as an external file. It's going to save it as an external BGO file. So you have to give both of those along. If you wanted to, like for me, if I want to share this with people and I want to stash a small geometry, this really isn't that big of a piece of geometry. So stashing this into a HIP file makes it more portable. There's actually nodes that do this internally to keep things from updating all the time. For example, I think a skeleton node, if you're doing kin effect stuff, has a stash inside of here. So there is actually a stash built inside of here that stashes it and keeps it in the file itself. So if you had it like, and skeletons are like points and lines, like there's literally nothing to them. So it makes it so that they're not, so that you're not running into as much of a problem with the like volatility of the file and things like that. So it just makes it so that you have a more contained, file that you can share with other people, basically. So that is what a stash node does. Sorry, rocket launch is distracting me. I'm looking at rocket things. Sorry. Anyways, so yeah, that's what a stash node is for. So it's really more when you want things to be stored in your HIP file versus as external files. Obviously, you can have it where you're going to a file, so you can like do this, and now I've got this BGO file and stuff like that. And so now this is actually, I think, looking at an external file on disk. I'm just going to, there we go. Just going to move back to stash input, and that should be fine. Now if I hit stash, there we go. Great. So yeah, just it's more of a self-contained thing than a file cache or something like that. It's almost like it's more like a traditional cache node, just the straight cache node, which saves it into memory more or less. And it's also very similar to if you lock, or it's almost exactly the same as if you lock your node. Like if I did this would be almost well, you can't see it, sorry, because it's red. But if I locked this and you had geometry coming through it, it's almost the same exact thing. And that would save the data to your HIP file as well. This is just a very, actually has like a UI to it, and it's like manageable to work with. So anyways, that's what that is. All right. So we've got our volume rasterized here. We've got our temperature being visualized. Let's see here. There we go. Let's make that a bit smaller. I think that's a little too big. Great. That looks good. There we go. Okay. So we've got burn, divergence, temperature, and V right now. So let's start throwing in a pyro solver here and start to see what we're getting into. And let's set up our sourcing first of all here. We don't have density coming in because we're sourcing a burn, and that is going to turn into density. So let's delete that. Temperature, flame, which is burn, velocity. Do we have a just curious if that will initialize it. Oh, interesting. So that's actually very interesting. So this really is probably better to use. Okay, let's just do this. So we actually didn't even really need the divergence here. Whatever, we kind of set it up ourselves. So let's do this. Let's do divergence like that. We got our source scale here. I'm gonna get rid of this again, density. So we got temperature, flame, divergence, velocity. Great. So yeah, these quick setups are nice. There's some good things in here that you can pull up really quickly and get your sources kind of set up in a way that's helpful. Like here you can see is temperature, we've got this pull operation instead of using something like an add or an average or something like that. I think what it's basically doing is like helping to, it's basically not like setting it initially. It's got like this kind of acceleration and deceleration value for the temperature going up. So it's not like instantly like, boom, it's instantly this temperature. I think there's kind of some delay set up in there. And then here with the divergence, we've got that in source scale. We've got burn set to maximum. All right, let's just hit start here and see where we start going with this. Why would I remove density instead of just removing its value? Interesting question. So, in our case, what we're doing is we're actually sourcing the flame, and the flame will then source our density. Because we want it to start as a flame and then turn into smoke, basically, we don't want it to be, because we want it to be burning and then become smoke. Like if you look at this again here, and let's see if we can find like a wider angle of it. Like it's flame, like mostly flame for a long time. And a lot of this is actually the dust getting kicked up. Like if you look at like the core of it, it is primarily like flame when it's going up. In fact, we have a rocket launch right here, nice and easy to look at. So let's take a look at this here. And you can sort of see what's going on here and how far these flames will actually go. All right. So if we look at this here, yeah, it's a great shot, right? Well, not that one. Nice black shot. There you can see the flame, kicking out. But there you can see how long the actual, burning part of this is, right? And so, a lot of this, like if you see here, a lot of the this kind of incidental stuff is the ground, literally like vaporizing and rising up and turning into dust and ash and crazy stuff. So that really is a little bit misleading as to what's happening here. But what's actually happening is this, where it's literally flame until, this is 100 meters tall, right? So it is flame for, primarily flame for over 100 meters coming out of the back of that. So, yeah, there's some intense stuff going on there. So that's why I'm doing it that way, because we want it to start as flame and then turn into density. And there's controls in here that will set this up as well. So if we go to fields, yeah. So if we do this, we can have density and emit that from the flame, right? And so right now we weren't getting that, but we should be able to get that here now. If we have this going, we should see that we're going to start getting density. Yep. You can see here. Let's do a little A/B test here. That's obviously very, very low density amount. And the dissipation should be like next to 0. Also, we're getting quite a few voxels here. So let's turn our scale down a little bit because this is going to be crazy. All right, so let's do that. Yeah, obviously we don't have enough speed here. Also, the buoyancy is going way too quick. And lots of other things are obviously not working in our favor here. But there we go. Okay, so let's start playing around with this and seeing where we can get with it. No. So Zach is just saying there, sorry, I missed your comment. Overall game plan is one pyro solver for the flame and another source and solver for the smoke. No, not in this case. I don't think I would do it that way. Unless people have had success with that, but I think that's the game plan here, is that you just do it with one source here, and then you have your other volumes being sourced from this. I am going to turn up my maximum substeps here. Just to give it a little bit more room because this is going to start moving pretty quickly. Let's do something like that. So let's add some more velocity here because I don't think we have enough. Let's look at this and see. Okay. We're going to turn off some of these visualizations. There we go. Let's try 100. And we're going to let's do a little more of this here. Oh, interesting. Why is that? Oh, sorry. I didn't realize how high I went with that. Oh, that's funny. I thought I went to like 20 or something. That was way too high. It's like, why is that so big? Okay, let's do that. When I come to it, if you know, in microsolvers, explain the control and threshold field and what the range of both of them dictates. Yeah, we can talk about that. Hi, Carlos. Recently needed something similar. Ended up using the OpenCL type, which was super fast. Yes, so that would be under minimal OpenCL. This one here, I'm guessing, is what you're talking about. For that, you need a little bit of a different way of sourcing everything. Also, it's going to compile my kernel, so I'm going to give that a second. So yeah, you'd have to do the sourcing a little bit differently for that. I mean, probably I should be doing this in Copernicus too, because that's actually very fast. But yeah, you need to source this a little bit differently. You need to do a, yeah, you've got to do some stuff with that. But yes, we definitely can talk about that. That is in the shape here. These are basically set up microsolvers. It's worth it if it's sim that fits in boundaries. Yeah, for sure. Yeah, that type of sim is very, very fast. The other thing I'm going to do here too is, let's see, how is the... Oh, what did I do here? Yeah, that turned on the limit source range, I think. All right, also, I'm going to turn this up a little here. I'll make sure I've got my memory going. Be careful with that. Don't go too crazy with that. All right. So we're getting some stuff going here. Obviously, we're getting too much. Yeah, we're not getting exactly what we were hoping for here, but that's okay. It's okay. We're going to get there. Here you can see that density is getting sourced from the flame, which is nice. Okay. So let's turn this on just to kind of get a little. Yep. Okay. Let's see here. It seems pretty reasonable, the bounds of this. All right, let's do a couple things here. I actually think that we want a little bit more cone angle on this. So let's try that. Let's see if we can't spread this out a little bit. Yeah, I'm not even using this as a collider right now, so that's why you're probably seeing some of this like a little bit leaking out there. Okay, so that's... doing something. Let's kick this up even maybe a little bit more. Still not happy. Let's get crazy. All right, the other thing I'm going to do here is I'm going to take this pyro solver. I'm going to do bounds. I'm going to say, oh yeah, here, I want to do the Y plane closed below 0. Just because we don't actually need that to be going any lower. Just makes it a little bit nicer to not have to worry about calculating below that point. Make it just a little faster. Would the velocity of the sim be the same speed of the rocket? Not in this case, no, because at this point, the rocket doesn't hit supersonic even, which is like, I want to say like 1,000 kilometers an hour, maybe something like that, until it's like a minute into flight. And I don't even know if it hits like Mach, like, I don't know, like 4 or 5 before those even fall off, right? So it's not going that speed. That is kind of the overall like progressive amount of velocity that's injected into it. That is not the initial velocity, right? So I'm not it's really probably, I think I've tried looking it up before, and it's probably possible to find some information on it, but I'm not sure if it's really well known what the, like, because if we go like, let's just get really crazy here. Let's do 1,000 there. Yeah, that's actually starting to feel relatively like nice. Yeah. It's actually feeling pretty good. I'm glad I talked through that a little bit. Like, obviously the exhaust, so what if I listen back to myself talking, what that sound of the crackling of a rocket engine is that it's actually going. Yeah, Pyro's always led with that mushroom shape. Yeah. There's some stuff that we're going to try, that I'll try to do to see if we can't break that off, but to see if we can't mess with that a little bit. But interestingly, this kind of stabilizes out at like a certain like size, right? Like, it's not really changing that much. Now, obviously, we're really, we're dissipating way too much. Like, that's what we're seeing here. I'm just going to look that up because I'm pretty sure I was right about, let's look up Mach number. Now that's also in air or whatever, supersonic, transonic. Okay. Kilometers an hour. Okay. Yeah. So honestly, you could probably bring this up to, yeah, you could probably bring this up to 1,500 and it would probably still be quite reasonable. I can hear the popcorn with the sim. Yeah, that's just my GPU yelling at me, or my CPU yelling at me. That's all it is. Okay, so let's play around with a couple things here. So first of all, the the density of this is a little suspect. We can go in and just do the look and up the density scale here, right? So like we could kick this up to 10 or something like that. And now we're at a much better spot here. The other thing, actually, I did change. Oh yeah, I forgot. Somebody did ask me about the thruster thing. Oh, sorry about that. I haven't ever even played with it. Shoot, sorry. I said we maybe could play around with that, and I totally forgot. Sorry, my little tiny brain got ADD'd itself. Okay, so this is starting to sort of do some stuff that's good. The one major thing though that we're gonna run into is you saw how long it took for that cloud to dissipate, right? And that's what we're dealing with here, right? That's the same thing. So like this should not be dissipating that quickly. And so if we come into our pyro solver here and go to our fields, let's turn this, I mean, I don't know. Let's try that. I mean, this is going to really stick around now, which is nice. It's probably going to expand our volume a lot in some ways, because it's going to, it's going to keep this volume kind of moving and shifting and stuff like that, which sort of isn't really what we want, but well, it is. This is what we want. It's just going to take up a lot more like time and memory and things like that to kind of calculate out. And you can see down there, the voxel count is rising. It's steadily rising. We're also getting some weirdness at the ground here, it looks like, but that might just be an artifact actually of just the sim resolution. Yeah, it's probably just the sim resolution that we're seeing there. We're just seeing some artifacting. The other thing, as I'm thinking about this, I sort of wonder if we don't want to turn up, and this might sound a little weird for a smoke sim. Well, first of all, I want to calculate the speed. I wonder if we want a little bit of viscosity. I kind of feel like we might. Just to kind of smooth it out a little bit, because it needs to really be like moving together, right? And that's what viscosity is. Well, we'll think about that in a second. So this is the flame range at which we're emitting density. Okay, let's try this. Okay, so we're at 0. Let's just do like, I don't know. Let's try 1. Let's just see what 1 does. I'm just curious, just out of curiosity here. And it's not going to be right, but it is weird. It is a weird looking thing that's happening, but kind of interesting. It's like we're shooting out a smoky snake. So what it's doing obviously is kind of smoothing all those velocity values out over like across each other, right? So they're all trying to kind of stay in this, like kind of all their vectors are trying to go in roughly the same direction. Billowy. Yeah, it's really weird. It's almost like incense. Because like incense is very like a viscous smoke. And that's what made me kind of think about this a little bit. Because what we're seeing here is actually it's a burning of a propellant. And so it's not just like smoke. It's not like water vapor. It's a little different. So that was what was making me think it's almost like a different kind of like smoke like that. Let's try this. Let's try like a quarter. Just see where that gets us. Because like just a little bit of that kind of staying in that shape might be really nice. And yeah, that like I'm starting to kind of like where that's going. Like that kind of feels nice because we've got this nice centralized, like this shouldn't be like flicking around like flames. You know what I mean? Like that's, there's no way to make flame more viscous and keep the smoke wispy. Well, I don't know what you mean by wispy, because we don't want this to be like thin smoke. We want it to be really thick. And we also want to, there's a couple more things that we need to put in here. We need to put in some turbulence, I think, for sure. We need to definitely put in disturbance. Maybe a little bit of wind would be nice, just so it's not just this static thing, right? But really, we do want there to be these kind of big moving, like we don't want it to be moving randomly and chaotically. We want it to actually kind of flow in a general direction. So, oh, different viscosity values on flame and smoke. Oh, that is interesting. It doesn't seem like that's the case. Because what you would do there is sort of like, yeah, you could certainly do, if there, maybe with a microsolver you could. I'm actually not sure. It's a good question. That's a good question. Zaid is asking, did you add density in the pyro source? No, I'm just doing the flame emission, and then the smoke is being sourced from the flame. All right. So what I'm going to do here is, all right, let's play around with this a little bit. Okay, so we have our field set up here. Oh, I see what you're saying. Yeah, yes, certainly you could. Yes, so yes, so exactly, you're right. So can you do a delay mapping it to lower temperature values? Yes, for sure, we could do that. So here in the emit from flame, yes, we can do this. Let me think of what we want to do here. Just curious here what the flame range is. Like what ranges are we seeing here? 0. Okay, 0 and 1. Okay. So maybe what we want to do is do this like point. Oops. Come on. Do 0.1 and maybe like 0.2, because before, what's it by default? 0.2 and 0.5. So let's have it go. Yeah, let's have it go down like this, maybe. Oh, another thing we could do too is, well, let's try this. Let's just see what happens here. Another thing we could try is, yeah. Okay, let's try this. In the sourcing, let's source the flame at like a 2. Let's see what that does. Does that change anything for us here? Oh, another thing too. That would maybe be another thing. The cooling rate. would be, let's turn this down a little bit, maybe. No? Really thought that might do it. Oh, no, sorry, that's the temperature cooling rate. Oh, maybe this. All right, I'm going to also do one more thing here. I'm just going to turn this off for a second. I just want to see what this flame is looking like without that. Okay. All right. Let me try a couple things here. I'm going to turn this off. Just curious if we have a more even flow, if that's going to do anything nicer for us here. I also think that this might need to be a little, just a touch higher. Is there noise on the flame values? No, there is not, because that is burn. There is divergence. Let me turn this off just to see. But there is velocity noise, so let's turn that off for a second here. Let's just turn all the noise off. Leave the speed. All right, let's just try another thing here. Shape. Let's up this a little bit more. So I feel like that should be more. All right, let's do. I'm just curious. I just want to add a little more of this in. Yeah, so I think part of what we're seeing here is let me just turn this back on, emit from flame. I'm just curious what that's going to if that's going to change anything. It's also like the speed is like not able to like keep up here. So that's interesting as well. Let's do this, I think. Okay. So the other thing, I think maybe this is too high. Let's turn that down. Okay. So in looking at this here, when you're in close to it, I think what we were seeing is some of this right here, right? And so that is a little bit of what we're seeing, and we're seeing a little bit of some of this, I think. I think it's cooling and looking a little differently because it's not getting like pulled down by, and like it's not moving forward, right? So I think it's a little bit different when it's on its side like this. So I think you're going to see slightly different results from it than if it was moving upwards, right? Because it's kind of, yeah, it's working in a different way with, you know, gravity and things like that. So I think it's slightly different. I'm feeling like we're getting, I mean, obviously this is insane. Like this looks crazy comparatively. But we're getting somewhere here. So let's just see what this looks like. I'm gonna do a little flip book here. Just see it in real time. Yeah, I'm actually pretty happy with how that's looking, honestly. I mean, there's parts of it that need to get changed, like it's too billowy still. But we can work with this, I think. Yeah, it's definitely like, I mean, it's not perfect, but it's doing some cool things. Oh, sorry, I didn't see there was a question there. Turbulence, disturbance, and other parameters in the shape tab. Yep, exactly. Yes, those are ways that you can go in and tweak some of these values. So for example, I'll just stop this for a second here. So these big kind of shapes here, these really soft, pillowy looking shapes, or like mushroom cap shapes, those are really affected and kind of removed by using disturbance. And so that's a real key here. And that's also why I've turned on the, yeah, it is fun to look at. I do like it. So that's why you turn on this disturbance here. So this is going to, we'll keep this. I'll make a new sequence so we can kind of see the difference between it. So the base block, so there's a couple things here. This is going to be adding in noise for us, and it's going to add it into where the density is. So we're going to be adding this into, no, we're using this for the threshold of where this is happening, and this is going to be disturbing the velocities. And so what we're going to be doing here is we're going to add some disturbance in here. Let's turn this up a little bit, maybe to like 2 or something like that. And this block size here is, I feel like I usually use this. Continuous you could do too, but I feel like block size is nice, and that's, I feel like I get the, I don't know. This is what I'm just going to do here. I think if we use continuous, it can be a little weird. So let's do this. And I feel like we want to go a little bit bigger than this, because this is 2/10 of a meter. Actually, you know what? That might be fine. What you can do too is if you want to put a box down, right? Like, and see the scale of this, right? You could just do like that. I've never used continuous in my life. Yeah, I feel like it makes too big of a it makes everything too disrupted or too disturbed, quote unquote. Let's make this a little bit bigger. Maybe it's like 0. Yeah, let's do like 0.4. Doesn't need to be much bigger, but let's do that. This is just for reference, so we can just leave that. All right, so what we should see here, oh shoot, you know what? Let me make a witness camera type thing here that we can use, because I just moved my view and it'll be nice to kind of A/B these. So let's just do this again and just close that. That's fine. We'll just call this witness cam. And there we go. There's our witness cam for our sim rocket. Cool. All right, let's flipbook that again. The value is the same as box size, and that's size of pockets of disturbance. Yeah, like the box size is like, it's almost like your noise scale, right, of this disturbance, more or less. No, I don't think it's within a box. It's saying, I think it's just a different way that the noise is being calculated. Here, you know what we could actually do? I'll let this go for a little bit longer. Yeah, gosh, I love simulations. Oh, it's so fun to watch. You could just watch it forever. The nozzle's a little toasty there. I don't have it in as a collider, but whatever. We'll just let it be. Still looks fun. My absolute favorite thing that's happening here are these areas right here where it's like literally like the flames are like shooting underneath these. They're like almost riding on this like insane jet of, you know, fire. I don't know. Pretty cool. I don't know if it's completely accurate, but I like it. All right. So let's stop that, please. Okay. So what we can do here is we can look at the disturbance and we should be able to turn this on. And if we start simulating this, let's do this in the YZ. There we go. Oh, I said Z. Why did I say Z? I've never said Z in my life. I guess I listen to too many. I work with Canadians, I guess. Maybe that's my problem. Man, my brain. So this is what the disturbance is adding to it. And so we should be able to adjust this and see the scale of it change. So here you can see it's basically changing like the scale of this noise, right? Like it's also adjusting the amplitude of it, it seems like, which is interesting. But there you can see it's basically like a noise that's getting added onto it. So we'll say 0.4, and we're going to use a control field here because we only really want this to be applied in places where we're below a certain velocity. Now in this case, let's look at our range of speeds here. Yeah, we've got 0 to 460, which is a lot higher than usual. So basically what this means is that we want to take this control range and we want it to only be really noising on sort of the fast moving areas, right? And so what I'm going to say is let's do this. Let's say 100 and no, let's do 1. And let's actually do this like 50. Let's find a good spot here. Okay. So what I'm seeing there is like, I want it to be applying on these really noisy areas and not applying where it's like basically stationary. So actually maybe something like that is going to be better. Yeah, let's try that. And I have a feeling we might actually need to up that disturbance even more. But so there you can see kind of what's happening with it and where it's getting noised up. Let's turn this off because that actually is really annoying, I feel like. Let's go back to our camera. H21 has compute range now. Yeah, I guess. I think that's been there for a while, actually, if I remember correctly. But maybe not. Maybe it is new and I just missed it. But I'm pretty sure that's been there for a little bit. Yeah, see, this really isn't, nothing's really happening here. And that's probably just because the velocities are too crazy. So let's try 15. See if that gets us anywhere. And what we should see is that those leading edges should get sort of, there should be some noise happening on those. And not really. And let's turn this down a little bit. Maybe 1 is better here. All right, I really think we want to turn this up more. So let's try 30. Let's double it. It's not in 20.5. Interesting. Yeah, I guess that is a new thing. So the control range is saying where should you basically be apply. It's almost like saying what should be like the 0 and 1 values of like you're multiplying into the range basically. So like the speed or the disturbance should be 0 below what range and should be 1 above what range, right? So yeah, I think it's just, this is a really, and like, let me see if I lower that down, if that makes it any better. Maybe it will. I don't know. We'll see. But I mean, our velocity going in was 2000. Is that right? I think. So, I mean, some of these velocities are all over the place, I would say. I'm actually surprised we weren't seeing quite that speed at the initial, but probably slows down very fast. So, okay. I think we're seeing a little bit of change here. Let me see here. Let's go to this here. All right, let's do a flip book of this. And then we can do some ABs here. I think the viscosity ruins the disturbance. It probably does make it harder for it to come through. That's true. But it definitely is happening. There's definitely disturbance happening. Like this looks more disturbed already. All right, let's do compare images and where's our, here it is, sequence list. Okay, so the left, let's swap those. Yeah, there's definitely stuff going on here, which is cool. All right, so I'm going to do this, and I think you have a good point there that the viscosity is definitely affecting it. Let's try going... Actually, before I do that, I'm going to try doubling this again. Because I think it's actually starting to come through a little bit. And we'll try another thing here. Oh yeah, there you go. You can definitely see it. It's getting less smooth. Yeah, I'm starting to really like. Starting to like where that's going. Okay, let's stop the comparison here and let's. Sorry, this is the one. So if we compare that to this, you can see how this almost looks like theatrical smoke on a stage or something like that. And this is now feeling like it has some more like weight and like, oh, would it be easier to do a top and bottom split comparison? Sure, we could try that. Let's see here, split vertical. That's weird. It like keeps jumping. So there's kind of the difference. The bottom one is the, here, I'll just do it this way. So you can sort of see that the more billowy version is in the top. Yeah, it's more like I want to rotate it. I want to have an arbitrary rotation of this. But yeah, you can see that we're getting this here. So that's good. I think there's a couple things we could still do here. Okay, let's try a few things here. So minimize this. Let's stop this. And let's try this. Let's go down a little bit in scale, just slightly on the block size. Let's up the disturbance to 100. And yeah, let's try that. All right, so this is comparing it to the last one here. Okay, so which one's which? I wish we should have a label on here. Okay, so the bottom one is the new one. Yeah. I think that's starting to look kind of the way I want it. Or similar to how I think it should look. That seems like it's doing some nice stuff. Like we've lost, just in comparison here, let's look back at this. We've lost all of these huge, goofy, kind of smooth features, and now we're getting some nice little details, basically. These little kind of pockets of randomness, and I think that's nice. Let's turn this off again for a second. Let's just see what this looks like in motion. Yeah, I'm liking what we've got going on here. It's fun. It's fun looking. The interesting thing is the thickness of the density is just being controlled by, you know, the shader basically. This is just a viewport shader, obviously. And what we would really want as well is to have scattering happening in this as well. So let's take a look at that. Under look. Oh, sorry. I need to just stop that. Oh, right. Okay. This is just a really basic visualizer. So let's do this. Let's what is it? I think there's just a, yeah, there we go. Create a pyro look. Great. Oh, it's too bad it doesn't use the values that we had. That's kind of annoying. Add that at 10, 25 on the fire intensity. Okay. Okay. Actually, let's do this. Interesting. Okay. Can I have a rocket launch for every stream? I mean, I could stream every time there's a rocket launch, but that seems a little, I don't know. Seems like that'd be tricky to do. I like rocket launches though. So yes, I would love to. All right, let's tweak this a little bit here, but I think we're getting somewhere nice. So let's do 0.5 here and let's turn this down a little bit. Yeah, okay. Okay, what's the default of this? Nope. Exactly. Yeah. You know, I was talking to NASA, and that's what I was like. You know what? You guys should really should have a rocket launch today. I think it would be good for you. And they were like, you know, that's a great idea. Let's see here. No, it should be a little bit less white, maybe. Like that's pure white. Probably like that. I don't know. All right. There we go. That's great. All right, let me go back to this witness camera and we start up a new sequence of this. A little nicer than a little nicer than the bathroom chocolate. Oh man. Got me there. Yes, I agree. It is a little nicer than the chocolate. Well, that's the thing. Life's like a bathroom chocolate. You never know what you're going to get. Yeah, I might have gone a little overboard with the disturbance, but I think it looks pretty good. I'm gonna say I like it, and we'll let that be. We'll let that be. But all right. You know what you're getting. Yeah, it's gross. That's true. Well, if you want to get the real way of doing this, you should probably talk to Urban Bradesco. He would be way better at this than I am, but I'm pretty happy for this, you know, for like it enough to send to a client. Cool, thanks. Yeah, so there we go. We've got some fire here coming out of a solid rocket booster, celebrating our some folks on their way to the moon. So yeah, keep an eye on the Artemis mission. Should be a cool thing to check out over the next coming. I think it's like 10 days. I think the mission's like 10 days long. I think their closest approach will be in like day 5 or something like that, day 6. So yeah, check with NASA. They'll probably have some cool events going on. Is there any way we can know what you're going to do before the live stream starts? Yes, certainly. If you go to the Discord server or check out any number of social media places, I usually don't really plug those that much, but the Discord server, I try to always put online, you know, hey, this is what I'm going to be doing. There's also places there to suggest things. Like if you're like, hey, I think you should do this, you can go on there. This one, obviously nobody suggested. I just kind of went with it. But you're welcome, Zach. No problem. Always happy. Folks that have been around for a while, I'm always thrilled to chat with. So thank you for seemingly always being here chatting. So I love it. Thank you. Thanks for not being too bored by me doing these things. Cool. Well, yeah, like I said, thank you all for being here and for watching and being a part of the stream. Thanks for thanks Lucas. Yeah, so it's always nice to have everybody here chatting and talking, and yeah, if you want to grab the project file for this, it'll be up on the Discord server, or on Google Drive. That there's a link on the Discord server. If you want to join the Discord server, you can go to houdinihangout.com and you can go and get a link there for the server. And yeah, it's a good place to have your questions answered by other people that are really good at Houdini. And from, you know, just if you want to chat about stuff or have questions or thoughts or you want to share things, lots of different places there you can share stuff. So with all of that said, thank you all for being here. Thanks for joining us. And thanks for putting up with, but just for being happy to go along with my silly rocket launch watching and commentating. Hopefully it wasn't too annoying to watch, but yeah, anyways, thank you all for being here, for joining, and we will see you all next time, and have a great rest of your week, day, night, whatever it is. Have a good one. We'll see you next time. Bye, everybody.